Alright, we're going to take a look at Ricardian models, obviously produced by David Ricardo, and we're going to have a look at how we can use them to calculate the labour point of equilibrium, the size of the wage purse, and the size of the rent after we're giving the marginal product, which is this point here, that's marginal product, and the wage. And with these two values, we can calculate everything else we need. So the labour point of equilibrium, we're going to be looking for how to calculate the wage purse and how to calculate the rent. So how are we going to do this? Well, first we have to construct a Ricardian model to help us visualize the problem. You'll probably be given these kind of questions in your economics classes, and they look a lot harder than they actually are. So once you get it, you're able to plug in from the marginal product, which is 200 minus 6n, with n representing the labour. Well, because that is the same as having a function of 200 minus 6x. So think about production functions for maths, where it's just a plus bx, a plus bx. That's basically all that is. So from that, we're able to draw a Ricardian model, so we're able to find the root and the intercept. And obviously to find the intercept, that is just the same as finding a. So a would just be 200, because the intercept is when x is equal to 0, so it would be 200 minus 6 times 0, which would just be 200. So that's why the intercept is 200 on the vertical axis. And to find the root, we would have to go and do minus a over b, which is just the same as minus 200 over negative 6 for the labour, which would give us a value of 33.3, which is what we can see at this point here. It's what we can see at this point here. So that's basically how we've drawn this Ricardian model. So that's how we found the intercept and the root to get this line, and the line represents the function f x is equal to 200 minus 6. That's the function it represents, and the slope is just going to be negative 6. Because the slope is always the same as b on the production function. So now we know the slope, we know the intercept, and we know the root. We can get rid of them, and then we can plot the wage on here, just looking at the vertical axis. I've just done it in arbitrary points, there isn't graph paper here, but obviously you'd use a scale if you were using graph paper. We were given the wage up here, so we just put it on. And then we got this point here, if I just draw that on quickly. There we go. This point here. Get rid of that. And then I'm going to draw a line on here, put that down to the x-axis, and we'll put a text box in here, and this is how we're going to be finding the labour point of equilibrium. So the dot I've drawn there, that is the labour point of equilibrium, and to calculate it we're going to have to go through a method that's a bit finicky, but it'll make sense in the end. So at the labour point of equilibrium, the marginal product is equal to the wage, because they've overlapped. The wage has hit the slope of the marginal product, so I hope that's fairly obvious. So that means that that's basically equal to 200 minus 6n, and we'll just do the stars. We're trying to find the labour point of equilibrium. That is the same as 80, and then we can rearrange this so we can go plus 6n on each side, which would just give us 200 is equal to 80 plus 6n. And then obviously we just subtract 80 from either side to get 6n is equal to 120. And then we can divide that by 6 on either side to get n is equal to 20. So that's that answer then. The labour point of equilibrium when the wage is equal to 80 is going to be equal to 20 on the wage. So yeah, that's the labour point of equilibrium, it's equal to 20. Now we're going to be calculating the wage purse, which is slightly easier. That's basically just 20 multiplied by 80, because obviously we've got 20 workers represented by the n there. In case I didn't make it clear before, that symbol is equal to the labour point of equilibrium, and we calculated before that is equal to 20 labourers. So 20 labourers are going to be paid the wage of 80 there. So since you've got 20 labourers, they're all going to be paid 80 each, because that's the wage. 20 multiplied by 80 is going to be equal to 1,600. And because the product that they are receiving is units of corn, the wage purse is going to be equal to a total of 1,600 units of corn given to the 20 workers as they each receive 80 units of corn in wages. So I hope that is fairly simple to understand, because it's not very hard. So the size of the wage purse would just be 1,600, because that's the total pay of all the workers required at the labour point of equilibrium. So that's that done. Now to calculate the rent, it's going to be fairly self-explanatory. Let me just add a thing on here, so that'll just be 20, just to simplify things when we're going to be calculating the rent now. So The rent is just the area of the triangle at the top, and we know to calculate area of a triangle it's just base times height times 0.5. That's basic high school maths. So what would that be? Well, the base is going to be equal to 20, I believe, yeah. The base is equal to 20. The height is going to be equal to 200. Minus 80 equals 120. Because obviously it's the difference between the 2 points there and there. For the triangle, fairly self-explanatory. 20 times 120 times 0.5, and that is going to be equal to 1,200 units of corn in rent. Corn paid in rent. So I'll just put that there, equals 1,200 units of corn. Now we can get rid of this. I'll just put in what each of these are being measured in to make it fairly easy to understand. And yeah, that's basically everything you're going to be asked on any kind of question talking about the Ricardian model in your economics exams. It's fairly easy once you grasp the fact that these are basically just asking you to work out points on the line based on like basic rules of functions, really. Obviously everything below the wage is going to be, everything in this square is just the wage purse, anything in this triangle is the rent. So yeah, that's it for calculating things with the Ricardian model.